Welcome to Savoir Labs, I'm Jamie Goodyear. In this episode, we're going to talk about our Raptor Computing Systems Blackbird Power 9 server. This video has not been sponsored by Raptor, we've used our own money to purchase this system, and we use it daily as part of our build hosts. Find out in this video about how we use this PPC64LE system and use it to improve Apache software. Up next. Let's fire up our Blackbird system. The boot process takes about a minute from cold start. We'll speed up our video and arrive at our CentOS Stream 9 login page. Why did we choose CentOS Stream 9 for this system? Well, we have a lot of support clients who actually use this for their PPC64LE deployments. Now that our system is booted, let's get into what's inside of our Blackbird build host. Our Blackbird system came as a 3-piece bundle set. The motherboard, heatsink, and CPU were included. Let's take a look at the motherboard itself. As we can see, the Power 9 socket is taking up the majority of this board. There are 2 DIMM slots, a PCIe 16X and 8X expansion cards, and a number of additional ports for our networking, lights out management, etc., and a collection of SATA ports on the bottom right corner. What you'll notice is that there are no M2 NVMe drive slots, so we're going to have to add a daughter board to get that into our system. Focusing in here on the actual socket, and now fully popular with the Power 9, this is the beating heart of the Blackbird. It supports up to the 8-core CPU. If you want to go with larger Power 9 CPUs, you'll have to upgrade to one of their other motherboards. They have a Talos product and a couple of other SKUs. This particular one is entry level, so it's going to only handle the quad or the 8-core CPU. That being said, it is SMT4 support, so we get up to 32 threads on this system. Here we can see the installed heatsink. You'll notice that in the very center of this 3U heatsink, there is a hole. What you do with that is screw down into there the retention clasp to keep that heatsink attached. You're going to have to purchase a special screwdriver to be able to reach down into that heatsink to firmly attach. Pro tip, do not put any thermal grease in there. You actually do not need to do that. Doing that could actually be detrimental. The community reached out to me when I originally posted about assembling this machine on social media, and they were very quick to tell me, yeah, no, you don't need to have that there. So I cleaned that off of my system and firmly attached it. And I've been using the system now for better part of, I think, a year, and it has been rock solid stable. So really, really cool. From this angle, we can take a look at the motherboard and see that height of that 3U cooler. Part of this means that we had to put this into a case that could handle it. So I put it into a 4U case, plenty of space and airflow around the whole system. For memory, we installed 2 DIMMs of 64 gig, 3200 megatransfer DDR4 RDIMMs into the system for a total of 128 gigs of space for memory. In this shot, we can see our Silverstone 500 watt power supply, and on the bottom, we have a 4 NVMe riser card. We only have that populated with 1 hard drive, but we can expand it quite a bit so we can get a lot of extra storage space and some additional performance. So, how do we actually use this system? Why are we using this PPC64LE machine? Well, we do a lot of support of Apache projects, focusing on Java, things like ActiveMQ, CXF, Graph, Camel, etc. When we're using this machine, there are 3 primary JVM distributions that we can use that are supported in PPC64LE distributions. We get Timirin from Adopium Eclipse, the IBM series of Simru IBM OpenJ9 branded JVMs, and then Red Hat OpenJDK. These are all very similar to Java, and you'd be saying, like, well, why do you need to have so many different JVMs installed and testing? Well, there's small differences between them. Right off the bat, the IBM ones are OpenJ9 based, which is a very fundamental different core to how the JVM works, and we'll find lots of different support issues where we need to have updates to support, say, different crypto or different ordering of native ordering that sets can happen inside of a JVM. The Red Hat OpenJDK, that's one of those few ones that come with FIP support right out of the box. Really neat feature of it. And the Adoptium line of Java JDKs that are out there, it's just widely supported in so many different architectures. It's great to be able to have that one to be able to do comparisons across platforms and just getting that OpenJDK compatibility across multiple systems. As a particular example of what we've used this system for, we did an extensive bit of work with the community helping Apache CXF get better PPC64LE support. This was across the different JVMs, so Red Hat, Semru, and Adoptium, and making sure that things worked nicely. We did multiple builds, we helped tamper down any unit tests that were breaking, and then we found lots of small edge cases where things such as native ordering, so keeping in mind that PPC is a different instruction architecture compared to, say, ARM or x86, x86-64. This is using the Power ISA, so certain things will be ever so slightly different. Also keeping in mind that some of these JVMs, they have different presets to what their security settings are, so some tests would fail because they're expecting things to be set up one way, and they actually run differently out of the box. So we were helping to make this a better out-of-the-box experience, and we saw that when we got to our CXF 4.10 release, and that was, all, of course, backported some of our older 3 series to make things a lot more stable. Another area that we worked in is trying to improve its stability and performance. We posted onto our blog our work we've done with a SOAP performance testing harness. In our blog, what we outlined was how we were able to set up our Power 9-based system and a separate set of servers to start sending in SOAP requests. SOAP is a relatively heavy protocol, and what we wanted to see was just how much stress can this server take. In our lab testing, and in our notes below, you can see our blog links. We were able to set up our system such that the PPC over a period of 8 hours was able to handle 1 billion, actually over 1 billion SOAP requests. Of course, we had a pretty large Java heap, and we had everything set up and tuned just so, and you can see the notes just how we did this. But it was amazing to watch this box be able to run 1 billion requests through without having an error, without really breaking a sweat. It was really neat to see. So now that we've talked about the system as a whole, let's go and actually get on the console and play around with this machine for a little bit. On the right-hand side of the screen, we have our familiar B-top. We can see all the CPU cores, the memory usage, how much disk space is here, our networking, and a listing of the processes that are currently running. On the left-hand side, we have our terminal open, and I currently have things set up that we can take a look at Apache CXF. I'm not going to dive into CXF code so much as just being able to show you that we have a project and generally what we'd be doing any given day. We pick out our project, we pull down the latest code, and we'll start running our regular builds. So, simplest thing might be just like a Maven install, and they'll start building things out, and we'll start seeing, hey, what unit tests may be failing, or if there's some integration test that might fail. That's just our general thing that we're always running these systems overnight or any given day. Now, when a bug is found or we find a particular issue in this, that's of course when we start, we create an issue, we'll go into Jira or onto the GitHub side and create an issue, create a branch, do our work, and then be able to start building our local builds, find out does that work for us here, try out those branches on other systems, make sure we're not breaking something else because, now that we've made it work properly on a PPC side, we don't want to break down ARM or some other platform. In our case here, what I have set up is Eclipse Adoptium. Of course, we'll try this out with stuff like Semru and with the Red Hat JDK. Just trying to make sure we get as much broad spectrum testing. And then when we're trying to debug, we have all of our local tooling. So this is basically what we do on these systems. But the most important part of this is the fact that we're doing on the proper hardware. We're not approximated by just taking, say, a Semru OpenJ9 JVM and throwing it onto, say, Ubuntu on a Xeon system, saying it's close enough. You really do want to have, the same shell, the same tooling, and the full operating system and ISA underneath it to really verify things are working properly. That being said, if you have any questions about the kind of work we do with PPC64LE support and what we do with Apache projects, Yeah, totally reach out, put some comments down below, and remember to like, subscribe, and see you on the next video.